Hey guys, so this is the last part of 3.7. I'm on page 304, and now what we're going to do is we're going to discuss whether we need to use factoring, the square root property, or the quadratic formula to solve different quadratic equations. So I'm going to kind of walk you through this to help you get a sense of this before I kind of turn you loose to try this on your own. So by far, factoring is probably the easiest method to use, right? So if you can factor, in general, you're going to want to factor. So for instance, if I look at A here, can I factor this? I can, and this factors as x minus 5 times x plus 1. And then you just set each factor equal to 0, so I'd have x minus 5 equals 0, or x plus 1 equals 0, so then I would add 5 here to get x equals 5, or x equals negative 1. So those would be my two solutions. So when you can factor, go for it. Now, the next technique that we had was the square root property, which that's going to be pretty clear if that's what you want to use, because it's going to have this type of setup, right? Where it's one thing squared equals another number. So it's super important to notice that the thing being squared is isolated on one side. So this is going to use the square root property. So in this case, then I'll take the square root of each side. So let's see, I'll have x plus 4 squared equals 25. Take the square root, make that plus or minus. So this is going to become x plus 4 equals positive 5, or x plus 4 equals negative 5. And now I just go through and I finish solving. So this is minus 4, so this will equal 1. Subtract 4 from each side over here, so this is x equals negative 9. So those would be my two solutions. So when you have to use the square root property, it's clear just because it's the one thing being squared. Okay, so now for this last one. This last one is an example of the quadratic equation, or for the quadratic formula. So take a look at this. If I try to factor this, what do things multiply to 7 but add to 4? Nothing, right? And this doesn't look like the square root property in that it's not like this, right? Where it's one singular thing being squared. So the quadratic formula is something that you want to use as kind of a last-ditch effort. When you can't factor, you can't use a square root property. So when that happens, then what you have to do is you have to go through and say, what's my A? My A is 1. My B is 4. And my C is 7. Now I'd highly recommend that you pause the video here and try plugging all of this into the quadratic equation and then check your work. So try to work it all out. Hit play when you're ready. So in this case, my answers will be x equals negative 4 plus or minus the square root of 4 squared minus 4 times 1 times 7. All of this divided by 2 times 1. Let's continue to work this out. So if I continue on with this, I have negative 4 plus or minus the square root of, so this is 16 minus 28, all of that divided by 2. And so then this is negative 4 plus or minus the square root of negative 12, all of that divided by 2. Now what I want you to do actually is I want you to plug in just the square root of negative 12, just plug that into your calculator. And if you take a second to do that, what you will notice is that you get something like a domain error or maybe not real. Your calculator is basically going to bark at you that it has an error. So the idea behind this is that this actually can't be done, not at least with real numbers. So you'd have to have a totally different number system to work with this, and that's just not the scope of this particular class. So when this happens, then you actually have a very simple interpretation. It just means that the solution is not real, so we can't answer this. So that's it. And you don't have to go any farther. Okay, so now what I want you to do is you can use each one of those methods only once. So pause the video and try them on these three. Hit play when you're ready. Okay, so these are a little bit trickier, I will tell you that. So in looking at this, you might notice, oh, hey, I've got this squared thing here, right? So this part here is squared, but it's not isolated. So you could totally get it isolated if you just subtracted off the 2 first. So then I would get 2x minus 3 squared equals 81. And now I can take the square root of each side. So take the square root, remember this will be plus or minus, so I'll just break this off into its 2 cases. So this equals 9 or negative 9. Okay, so now I just solve for x. So here I'll go ahead and add 3 to each side, so I get 2x equals 12. Divide both sides by 2. I'll write the solution up here. I'm running out of room. This is x equals 6. And then for this one, add 3, add 3. I get 2x equals negative 6. Divide both sides by 2. So my other solution will be x equals negative 3. So there are my 2 solutions. Okay, so now looking at b, so this has a GCF, so actually I can factor x out first. And then I can factor this a little bit farther. So now I have 3 solutions. So this is a little bit different, but it's still the same idea. So I have this times this times this. So if you're not sure what to do with this x, you just set it equal to 0, right? There's nothing to actually solve for there. So the first solution here would be x equals 0. Now, where will x minus 6 equal 0? That will equal 0 when x equals 6. And then where does x plus 6 equal 0? That will equal 0 when x equals negative 6. Okay, and now for this last one. So notice this does not seem to be factorable. Also, it's not equal to 0. So it would probably make our lives a little bit easier if we at least subtracted off the 7. And then we could get a better picture of what we're looking at. So I have x squared minus 5x minus 5. Okay, so now what I want to do is I want to just take a look at this. I can't use the square root property. Can I factor it? There is nothing that will multiply to negative 5 but add to negative 5, so we can't factor it. So we're going to have to use the quadratic equation, the quadratic formula. I don't know why I keep calling it the quadratic equation. All right, so this is a equals 1. My b will be negative 5. My c will also be negative 5. So if I set this up, I'll have x equals negative 5 plus or minus the square root of negative 5 squared minus 4 times 1 times negative 5. All of this divided by 2 times 1. So now let's just go through the order of operations. So this is 5 plus or minus the square root of 25 plus 20. All of this divided by 2. Let's see, I got to move over here. So this will be x equals 5 plus or minus the square root of 45 divided by 2. So now I have to break this up into pieces. So I have x equals 5 plus the square root of 45 divided by 2. And then I also have x equals 5 minus the square root of 45 divided by 2. So now just to show you what the decimal answer of this will be, this will come out to 5.85. And then this other one, this will come out to negative 0.85. So those are my 2 solutions in this case. So again, when you can't factor it, you're more likely to get kind of these crazy decimal answers. Okay, so we have just 1 page left, so let's take a look. So it says, let's revisit an old application. A ball is thrown upward from a cliff that is 30 feet above the ground. This situation can be modeled by this quadratic equation, where h represents the height of a ball after t seconds. At approximately what times does the ball achieve 42 feet of height? Okay, so you might remember this in the last section. We talked about this and what you have to do to solve it. So to solve it, you would just set this equal to 42. So if you flip back a couple of pages, you'll find where we did this. So I had to set this whole thing equal to 42. And at the time, we didn't really have a way to solve this without a graph. So we used the graph to actually figure this out last time. Now what we're going to do is we're actually going to figure this out using all these other methods that we have. So to do that, what I want to do is I want to subtract off the 42. So in general, you want to have your quadratic equations equal to 0. That's a best practice. So let's see. First, I will set this up like this. And now, by looking at this, you kind of want to think about, could you factor anything out of this? Well, technically you could factor out, let's say like a -4, which if I do that, that'll flip everything. This becomes 8t squared minus 16t plus 3 equals 0. But then you're kind of stuck trying to figure out what to do with this. But this is actually okay. So this part here, we can now kind of keep going with this. So how would I solve something like this? So you might want to just use the quadratic formula now on just this part. So if I did that, my a in this case, if I'm just using, again, just focusing on this equation here. So my a in this case would be 8. My b would be -16, and my c would be 3. And I prefer at least having the -4 out of this just because it makes the numbers a little bit smaller, so those are nicer to deal with. So now let's plug this into the quadratic formula. So maybe you want to pause the video and then hit play when you're ready. So I'll go ahead and plug everything in. So this will be 16 plus or minus the square root of -16 squared minus 4 times 8 times 3. All of this divided by 2 times 8. Okay, so I just want to point out, so the negative of -16 becomes +16, so I just wrote this as +16 here. So now let me see what I can do with this. So this will be 16 plus or minus the square root of 256 minus 96, all of this divided by 16. Okay, so let's see. I will just continue this down here, I guess. So this is 16 plus or minus the square root of 160 divided by 16. And so just now in the interest of space, I'm going to just tell you what the decimals should come out to. So you should get that x equals 1.79. Let's see, maybe I'll give myself just a little bit more space. X equals 1.79, or x equals 0.21. Now, if you go back to our graph, this was in the last section that we talked about this, you'll see our old predictions. So this is in seconds. So we did actually talk about when we threw this ball, there would be 2 points in time where the ball would go up to 42. So I said it would go up to 42 and then it would come back down. So like there was like this line going over this way. So those 2 points in time now, this first point is this 0.21 seconds. And then this next point would be this 1.79 seconds. So those are kind of the two points that we found, but now we have a much more precise answer. Okay, so we have just one more to look at here. So this is something a little different. So it says you want to create wood frames to sell on your Etsy shop, and the frames need to hold a 12.7 centimeter by 17.78 photo with a wooden border around the frame, and the frame cannot exceed 80 inches squared. Model this situation and determine how many inches wide the frame should be. Okay, so I have a picture. Here's my picture. And right now I have these dimensions of 12.7 centimeters and 17.78 centimeters. But then I'm told that the frame cannot exceed this 80 inches squared. So you can see right away that you're going to have to make a conversion here with the centimeters. So let's start there. So let's use the fact that 1 inch, 1 inch is 2.54 centimeters so that we can convert kind of the dimensions on the photo. So starting with 12.7 centimeters, if I want to convert that to inches. So remember with dimensional analysis, so you want to use this little conversion here, and you want to make sure you set it up so that the centimeters drop out. So if you're going to decide where your centimeters go, on top or on bottom, they have to go on bottom, like this, because this will allow this like kind of opposite relationship so that the centimeters drop out, and then you just fill in the rest of the conversion. So this entire conversion, 1 inch equals 2.54 centimeters, it has to be represented exactly in this fraction. It's just you're just deciding what goes on top, what goes on bottom, but you have to use this whole conversion. And so now I can actually see what I need to do with this. If I try to kind of put this all together, I need to take 12.7 divided by 2.54, and that will get me to inches, which will come out to 5 inches. Okay, so that's the first one. So now let's do the other one. So I've got 17.78. So same thing, right? So this is still in centimeters. So I should write centimeters here, centimeters. And then here's the 2.54 centimeters. Here's the 1 inch. So now I'm going to cross those out again. So now I just need to take 17.78 divided by 2.54, and that will get me to inches. And that comes out to exactly 7. So now what I want to do is I just want to update the dimensions on this photo now that I've done that dimensional analysis. So now let's call this 7 inches. Maybe I'll write it in here actually. So this is 7 inches. And over here this is 5 inches. So let me get rid of all this. And going back to what this problem was actually asking about, so let's see. So I have to have so here's my photo. It's a 5x7 photo. And I want to have some border around it, but it cannot exceed 80 inches squared. So what I want to think about then is what should this frame kind of look like? So the frame is going to be the same width all the way around. So now I have to kind of take into consideration, if I add in the photo with the frame, what would this width here be? Well, it would be x plus 5 inches plus x. So my width in this case is 5 plus 2x. And then what's my length in this case? So I go from x, and then here's 7, and then here's x. So this will be 7 plus 2x. So I'm told here that my area is equal to 80 inches squared. And what is the area of this shape? Well, it's length times width, so that has to equal 80. So now I just have to replace it with these pieces here. So this is, so let me actually just go ahead and do that. So this will be 5 plus 2x times 7 plus 2x. This will equal 80. So now what I have to do is I actually have to multiply this out to figure out what do I actually have. So if I start multiplying this out, I get 35 plus 14x plus 10x plus 4x squared, and all of this I know is still supposed to equal 80. Okay, so let's collect our like terms on one side now. So I get 4x squared, I'm also putting this in descending order, 4x squared plus 24x plus 35, so this all equals 80. And so now I can see this is something quadratic, but I really need this set equal to 0 because that's just a best practice. So now what I want to do is I want to subtract off the 80 so that I get 4x squared plus 24x minus 45 equals 0. Now this video is already getting pretty long, so I'm actually going to just kind of tell you if you want to finish this off. So you're going to want to use the quadratic equation here to finish this. And if you do that, so you're going to end up with the solution x will equal 1.5, So you'll get actually two solutions here. One will be positive and one will be negative, but you'll want to take the positive one because obviously you can't have a negative border. So if you were to actually work this all out and use the quadratic equation, so this is something that you can do on your own, then, or by the quadratic formula. I really can't talk today for some reason, by the quadratic formula. So if you were to work that out, that's what you should get. So just to keep this video shorter, I'll just cut this off here, but that would be the idea. Okay, thanks for watching, guys. That